Thanks for coming to the Nuprime lecture. So a little bit about the company history. So a lot of people in the industry knows me as the CEO and co-founder of Newforce, which in 2005, I think that was the year where a few Class D amplifier companies come onto the scene and introduce Class D amp technology that basically able to compete with Class A amps, right? But in 2014, when Newforce was sold to Otoma, a projector company, me and our partner, which is the factory, decided to take over the high-end business of Newforce and created Nuprime company. So throughout history, we are one of the few companies on the market today that still do the high-end Class D R&D, because a lot of companies claim to have Class D products, but actually they buy from the off-the-shelf suppliers. So we do all our original Class D technology design. So historically, Class A amplifiers are being considered as unique, and a few of them has become collectibles, right? They are recognized as amplifier with characteristics. Class Ds has been known as clean and low power and compact, fast, but there's some criticism. The common criticism of Class D devices is that they lack characteristics, right? They lack personality. So, so how do we basically create personality for Class D devices? And that is the focus of today's talk. Before we go into that, I'd like to point out a few very notable innovation from Nuprime. First of all, as I mentioned, we design practically all the technology in-house, the amplifier, the DAC. Yes, we do use off-the-shelf DAC chips, but the entire DACs, power supply, including power supplies, are all designed, manufactured in-house. And we can claim that we are probably the only one Class D amplifier on the market today that can do 700 kHz switching frequency. Yes, when Newforce started in 2005, the switching frequency was around 350, 400 kHz, and over the years we gradually increased. What's the big deal about high switching frequency? Because Class D is basically pulse width modulation. So the higher the switching frequency, the more refined and smoother the sound becomes. And another key innovation that we created this year is 1 mega ohm input impedance for the Class D devices. Yes, 1 mega ohm, some of the pro audio products has 1 mega ohm, but on a high-end audio, how do you create a 1 mega ohm input impedance and yet sounds really, really good? So that is the challenge. So let me start with the design methodology. How do we create different characteristics? First of all, we have to model, right? So we model a tube or a solid state amp, right? And after we perform the computer simulations, then we use the Class A transistor to create the same type of sound characteristics as the Class A devices. And then the Class A, the transistor input stage combined with the Class D power stage, it forms the unique so-called personality of the Class D products. So, and here you can see I'm showing two of the examples. IDA8 is a sort of entry-level integrated. So there is a Class A transistor input stage. So we don't use op-amp for this device. And on the higher end, Evolution 1, of course, the Class D input stage has a 1 mega ohm input impedance plus the Class A transistor circuit. So that's how we differentiate the sound. And then in combination, so here goes into more details about various products. Basically for a Class D product, you have the power supply, and it can be a linear power supply or switching power supply. And we use either one depending on the requirement, right? And the Class D power stage has full bridge or half bridge. And the preamp stage, you can use op-amp, and that's what most people do. Or you can customize the sound by using transistor circuit. So here are few different products. For the IDA 16, basically when we started to conceive a product, we have a certain idea about how this product is going to be used by a certain type of customers and for what type of speakers and systems. So for IDA 16s, it was designed to be neutral, very clean and detailed and powerful sound, right? So it's not warm, it's very neutral. So for that design, a high-end op-amp with a switching power supply does its job. And IDA 16, when it was introduced in 2015, it won 2 Product of the Year award in America and a bunch of other awards around the world. Then later on, when we started the ST10, yes, we wanted it to be really smooth, smoother than IDA 16 and better, more dynamic, more refined sound. So we went with a full bridge Class D power stage, but still maintaining using the op-amp because we don't need to create the type of warmer sound for ST10. And in fact, actually, a lot of people, customers prefer the ST10 over many type of amps. And it's also won 2 Product of the Year award. So when we started the IDA 8, it's an entry-level integrated. And because a lot of entry-level speakers are harsher, so we want this amp to be warmer, has a lot more warmer sound. So that's the reason why we choose to use a Class A module, transistor module, to tune the sound. And when we started the ST89, it was a product positioned for customers who prefer even warmer sound, or tube-like smoother sound. So it was modeled after tube Class A devices. Then the MCX is another version that is suitable for both music and movie. So you can see from various products, they are all tuned to be positions for certain type of usage scenario and personal preference, music preference. So we are one of the few companies on the market today that basically can customize pretty much every aspect of our product. So far, any questions? Good. So yes, and basically you can see from the open case right there, the top of the line. Evolution DAC, and here is the this is the Evolution M. It's not clear. Yeah, see here. This is the transistor logic that input stage with the 1 mega ohm input impedance. So, and this is a Class D power stage, the power supply and the capacitor bank. And this is the MCX multi-channel M. And again, here is a bunch of transistors that tune this, customize the sound. So you can see various different products using either linear power supply or switching power supply. So everything is designed and manufactured in-house. And yes, over the years, we have won many awards from Product of the Year. This is from France. And there are some other awards that I didn't show. And to my surprise, so a very pleasant surprise this week, and we were surprised to have received 3 top awards in Germany, and these are recommended by chosen by the users. So looks like we have quite a following in Germany. While we can't always design product that is energy efficient and environment friendly, because serious audiophile, they demand certain level of performance, right? And in some cases, a linear power supply is quieter than a switching power supply, right? So if the customer demand that and they are paying top dollar for it, so we have to mix and match the right using the right technology for the product position, right? Okay, yes, good, very good question. So there are a few things. One of the most important issue is the switching frequency, right? Because Class E is pulse width modulation. So the higher the switching frequency, that means it gives you more refined interpretation of the modulation of the original analog signal into the pulse width. So and basically at 700 kHz and actually at more than 500 kHz, you can't really tell that it is the switching devices. Exactly. That is not because he's a very person, right? He's a one of the top engineers in Class D in the world, right? One of the top. But Hypex is a company. They are very good. They can do a lot of things that we do, but their company is designed to mass produce high-end amplifier module for multi-channel amp for the large people who buy in volumes. So you can't really keep customizing. It's not their business model to do a lot of customization. But we do our own research and development, right? So we develop the technology for our own use. So we can spend the time and the effort, and of course the resource and the cost, right, to customize our amp. You know, we can spend the time to push the technology to 700 kHz, which is very, very difficult to do, right? And it's not the goal of Hypex or other company to do that. We can continue to push the limit. So that differentiate as the switching frequency goes up, the sonic characteristic becomes smoother and smoother. So, and some of the customers of New Force from reference line and even to various generation of different Nuprime products from the entry level STA9 to Evolution DAC, Evolution M. As you hear the difference between besides other characteristics, you hear that the higher performance, higher switching frequency it gives you the smoother and more details. So that's one key differences. Another thing is the input impedance. So for this top of the line product, we have 1 mega ohm input impedance, and that makes the source device can drive the power amp effortlessly. So that means even more details come through to the music. And of course, there are a lot of other refinement in the devices. So but the key thing is the switching frequency, the input impedance that makes our Class D. And of course, as I mentioned, those are the technology that make the Class D devices sound really smooth, very detailed. But to add the soul to the Class D devices, you do need to model it after a Class A device, right? So that's what we do here. And but doing this is a lot of work. Basically, for every model, you have to spend the time to craft the transistor logic, and you can't mass produce this sort of stuff, right? It's costly to do. Yes. So a lot of a lot of customers who do basically blind tests, you know, if you don't tell them that the Nuprime product is Class D, they can never figure it out. And I think you have a question, back to your question regarding the power supply. So in some cases where you need a lot of power and a switching power supply will be more suitable for in a multi-channel environment, right? Yeah. I think that's pretty much it. The few key points that makes the product. But even though it's a few key points, but it takes practically a whole decade to realize that. And one thing I would like to add is that every year when we have new devices coming onto the market, we thought that we have accomplished everything that we need to do, that we're pushing towards a limit. But I tell you that from what I have seen in the lab, we are still pretty far away from what the limit for switching for Class D devices is. So I believe that the Class D with the right design can really surpass all the Class A devices. Yeah, because based on what I have seen in the lab. I think not in this. Audio might have. So generally we don't do a lot of live demo at the show because we already have a distributor that does regional demonstration. All in Germany, they do that several times a year. And recently in UK, Wilson Benash, the famous speaker company, just decided to pick up the distribution for our electronics in UK. So you can go and visit the dealers just about everywhere. Well, basically what we have shown, right? Any even incremental improvement usually takes about a whole year. So what you have seen here, for example, this Evolution DAC, the latest one, right? That can do 1 megaohm input impedance and 700 kHz switching frequency. The project started more than a year, 18 months ago. So it takes time to do the computer simulation, the modeling, the prototyping, and then when you get to the sound, then you hear, oh no, there's this little problem here, little problem there, then you go back to the drawing board and redo. And in our lab, we have actually started to use GaN devices, So, but that will take at least probably another year to 2 years before it appears on the market. Generally, we basically use monitor speakers. We don't play around with a lot of speakers. Because for us, we need to do the absolute test. But of course, before we go into the market, we send our product to our golden year distributors and audiophiles. So they will tell us, how they perceive. So yes, even though we are an engineering company, but we design everything based on science, but we do a lot of listening as well. But only after we perform the engineering work. So we don't do a lot of trial and error. Well, let's try this and see how it works. No, we start with the simulation, with the theory, but the new product is always very expensive. And from what I heard from the device company, we are probably the first company in the world that actually make it work. It takes work. It has the potential. What I can say is that otherwise it would be on the market, right? Yes, but it's very cool when you can put your hand right there and touch it and say, wow. And in terms of switching frequency, actually in the lab, we can do up to 1 gigahertz now. 1 million hertz. Okay, if not, I'll end the lecture. Yes. Thank you.